So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily problem of bitwise XOR of all pairings, and now we have to discuss their problem statement, and after that we have to discuss their example test cases. So now in this problem we have to given a zero index array nums1 and nums2, and which consist are non-negative integers, and we have there has exist another array of nums3 which contains the bitwise XOR of all pairings of integers between nums1 and nums2, and every integer in nums1 is paired with every integer in nums2 exactly once. So now, and we have to return their maximum XOR of all integers in nums3. So now let's discuss their problem statement, and after that we have to dry run their example test case. So here first we have to given to calculate the bitwise XOR of all integers, and we have to calculate with nums3, and which is generated by pairing every element from nums1 with pair with every element with nums2. Okay, so and after that we have to calculate with their XOR. And now our key observations. First we have their pairing rules. The pairing rules, like each element of nums1 is paired with each element of nums2 exactly once, and this is our first key observation. And the second one is XOR properties, and our XOR properties are when x XOR 0 is equal to always 0, and x XOR 0 is equal to x, and same thing for x XOR x is equal to 0. And whenever the same number of XOR we have to perform is always 0, and one is another number and one is another number, then the XOR of this one is x. Okay, and the third key observation is and the third is the goal is not to actually construct a nums3. We have to not construct a nums3, but we have to compute its XOR which is present in nums3. Okay, like whenever we have to create a nums3, and we have to calculate their XOR values, and the constraint we have to given on the constraint one less than is equal to nums1 dot length and nums2 dot length less than is equal to 5. It is a large input size, means constructing nums3 up to the size of 10 to the power 10. Okay, and it is feasible, and we have to given here like nums1 comma nums2. Okay, nums1 of I and nums2 of j less than is equal to 10 to the power 9, and the values are non-negative integers. So now let's discuss their example test cases. So first we have to given a nums1, and here nums1 is all here is 2 1 3 2 1 and 3, and then same thing for nums2 we have to given 10 2 5 and 0. And now let's dry run this example test cases. And so first we have the possible XORs of nums1 and nums2 to calculate with their XOR with their binary representation. So now nums1 of I is we have to given with this value only. We have to calculate this XOR into these 4 XORs, like Now first we have to create a table. Nums, one second, here nums1 of I, and here we have nums2 of j, and the binary representation of nums1 and the binary representation of nums2. And after that we have their jar value. No, sorry, we have their jar value, and after jar value we have their jar result, binary jar. Okay, so now first we have here 2, and second is 1, 1, 1, 1, and 3, 3, 3. 1, sorry, we have to calculate with 2 into 3 times, 4 times, so we have to calculate with 4 times. 2, 2, 2, 1, 1, 1, 1, 3, 3, 3, 3. So now let's calculate this. So first in 2 we have here 10 to 50, 10 to 50. Same thing for this one, 10 to 50, and this thing 10 to 5 and 0. So now calculate with nums1 with nums2, and so this value representation of the value representation of 2 in binary form is 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0. And same thing for 1. 1 we have to calculate with 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. And for 3, 3, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, and 1. So binary representation of 2 value, this 10, how to represent this? 1, 0, 1, 0, and 2 we have to represent with 0, 0, 1, 0, and this 5 we have to represent 0, 1, 0, 1, and same thing for we have to repeat with 0, 0, 0, 0, and same thing for all 4 conditions. Okay, so now let's write this with 1, 0, 1, 0, 0, 0, 1, 0, and here 0, 0, sorry, 0, 1, sorry, 0, 1, 0, 1. Okay, 0, 0, 0, 0, and so same thing for this one is 1, 0, 1, 0, 0, 0, 1, 0, and 0, 1, 0, 1, 0, 0, 0, 0. So now let's jar of all 2 values here and here. Okay, so so jar of this one is we have to calculate here like 0, 0, 1, 0, and 1, 0, 1, 0. Same value 0, same value 0, same value 0, and if one value is another value, like here 1, here 0, the jar of this one is 1. So the representation of this one is 8, so here is 8, and here 0 is 0, 1, 1, 1 is 0 because same value, so the whole is 0, so the binary representation of 0, 0, 0, 0 is 0, and so here 0, 0, 1, 0, 0, 1, 0, 1, and the representation of this one is 1, 1, 1, 0. One second, 0, 1, 1. Yeah, so here we have 1 2 and 4, 4 to 7 1 8, because of this is representation of this one, like this is 1 1, this is 2, this is 4, this is 8, this is 16, this is 32, like this we have to calculate. This is 64 and like this. Okay, so here where 1 1 is present, so yeah, here and 4 to 1 is equal to 7, so this value is 7 and here the value is 2. So now let's calculate with all these are same, like here is 11, here is 3, here is 4, here is 1, here is 9, here is 0, 1, 1, 1, and here is 1 2 3 6, here is 0 0 3, and now the total jar now jar calculate with their jar values, and the jar of this one is 1 0 0 0 and 0 0 0 0, and 7 7 in binary form is 0 1 1 1, and 2 is 0 0 1 0, and now calculate with this one is and 1 0 1 1 0 0 1 1 and 0 1 0 0 and 0 0 0 1, and same thing for this one is 1 0 0 1 and 0 0 0 1, and now 0 1 1 0 and 0 0 1 1. So these are our representation of binary representation. So now let's calculate these values. These are our nums2, basically nums3, sorry, nums3 array 1, and now calculate with their jar values. So the jar result we have to get here is jar result is 8072 and 11 3 4 1 and 9 1 6 and 3. So these are our jar values. So now let's calculate with one to another, one to and this one, like this. Okay, now explain this one. So first we have their jar of 8 jar with 0. Now the binary representation of this one is 1 1 0 0 and 0 0 0 0. So jar of this one is 8. We have to get here 8. So now these two values are become 8, and now jar of next one. So now 8 jar 7, 8 jar 7, like these two values jar with this one. So now the value of this one is 8 9 10 8 9 10, 8 jar 7 is 15, 8 jar 15. Now these three values become 15, and now jar with 2, 15 jar 2, 15 jar 2 is equal to 13, and now so on we have to calculate, like we have 13 jar 11 is equal to 6, 6 jar 3 is equal to 5, and 5 jar 4 is equal to 1, and same thing for 1 jar 1 is equal to 0, and now 0 0 jar 9 is equal to 9, 9 jar 1 is equal to 8, and 8 jar 6 is equal to 14, and same thing for 14 jar 3 is equal to 13. So this is our answer. Now here you have to get here 13. So now you have to calculate with, like we have to calculate these two values, then we have to jar with next one. Now three values we have to calculate, we have to jar with next one, and so on. We have to calculate with all these values into same positions. So final we have to get their binary. This is the binary representation of 13 is 1 1 0 1, and the answer is 13. Okay, so now let's discuss their key ideas, like how we represent their binary. and this binary representation helps to flip during JOR operation, and a bit is flipped when the corresponding bits differ. And efficiently we have to don't need to generate all pairs explicitly, and uh, uh, we have to directly JOR of all values with their corresponding values. Okay, so this is our time complexity of the O of n plus m for these operations. Like, we have not calculated with all previous values, like we have not gone before, we have only this one, and फिर on again this one, and because we have to calculate previously, we cannot track again and again. So that's why O of n plus m. So now let's discuss their coding part. So here we have, now first we have to define their size n1 n2, this n1 n2, and after this we have their answer. This answer is to store the JOR result. And now we have there this purpose of this line. The n1 is the size of n1 nums1, and this is the odd value using n1 and 1, and if it's not odd, then we have to JOR all operations with nums2, and we have to accumulate with their result into answer. Okay, and so use of this one is, we have to each element of nums2 contribute with final JOR value, and if every element is nums1 pairs with every element of nums2, this happens with n1 times. So time complexity of this one is O of n2, where n2 is size, and same thing we have to perform with this n2, this odd values, and to check with their JOR, and we have to accumulate with their answer. And this time complexity is O of n1, and this is nums dot size. And after all operations we have directly written their answer, because we have to calculate their JOR value. And so it provides the output that the function is JOR calculations, and the properties and the observation we have to take care, like the the JOR cancelling. The JOR cancelling is, first we have when an even number of identical values are JORed, they cancel out, and this is why we have to check with odd dot size of arrays all time. Okay, and now optimize JOR contributions. Like, if n1 is odd, each element of n2 is contribute with their JOR, and so same thing for n2 is odd, their n1 contribute with their JOR value. Okay, so now the time complexity of this code is O of n2 for iterating nums1 for a first half, and the O of n1 is iterating through nums1, this is nums2 and this is nums1, if n1 is odd, and same thing for if n2 is odd. So the total time complexity of this code is O of n1 plus n2, and the space complexity of this code is, we have to declare with n1 and 2 answer, so that space complexity is O of 1. So I hope you understand the logic behind this code and their implementation part, like how we can calculate with nums1 and nums2, and with their binary representation. And so you have to observe with their values, and their first you have to take care their visualization. And this is our visualization part, like how you can find their JOR values for nums1 and nums2 for each values. And we have to take care their time complexity, and we have their finally we have to find their binary JOR. And so this is the main part when we have to track with these two values, then these three values, these four values, and so on. So we have to find their actual answer and optimize answer. So thank you. So I hope you understand. So thank you everyone, thank you so much.